scientific death.
In a smoke-filled boiler room at Oregon Elementary School, a maintenance contractor crawled across the floor on his hands and knees. Ahead of him sat an empty, massive industrial boiler running without water. The metal base was glowing red, distorting under temperatures above 1,200 degrees. When confronted with a roaring, out-of-control fire, the human brain typically defaults to a single panicked instinct: throw water on it to cool it down. But this animated diagram shows what actually happens when water meets an overheated, dry boiler. In that sealed, superheated environment, a single drop of liquid water flashes into steam instantly, expanding violently and creating a massive outward pressure wave. That rapid, uncontrolled expansion turns the heavy steel tank into a low-pressure bomb. The force pushes violently against the inner walls, threatening to fracture the metal and easily level the entire room. Surviving this situation requires fighting your basic instincts. You can never introduce water. The very first step is to shut off the main water supply valves to ensure no liquid accidentally floods the superheated chamber. Only after the water is safely secured can you shut down fuel lines and the power sources. Once that strict sequence is complete, the only safe option is to evacuate the area and let the equipment slowly cool on its own. A trained contractor knows that specific sequence. A passing custodian or teacher does not. Without bold, explicit warning signs posted on the boiler room doors, a simple lack of communication becomes just as deadly as a mechanical failure. Today, we treat industrial steam systems with intense caution, burying them behind locked doors and rigorous regulations. But in 1867, one inventor looked at this explosive force, strapped it to a wooden frame, and decided to sit directly on top of it. We usually give the German engineer Gottlieb Daimler credit for inventing the motorcycle. He built a gas-powered, two-wheeled machine in 1885. But 18 years before Daimler's machine, an American named Sylvester Roper had already solved the problem. The Smithsonian recognizes Roper's 1869 machine as the true first motorcycle, an unregulated rolling steam engine. The mechanical layout was terrifying. Roper built a custom iron frame. He mounted a charcoal-fired grate at the bottom and suspended a heavy metal water boiler directly between the two wheels, right above the fire. To save space, he combined the rider's seat with the water reservoir. The rider was literally sitting on the water supply, straddling an active firebox. Operating it required a completely new control system. Roper designed a solid wooden handlebar that functioned as a twist-grip throttle. By rotating the entire handlebar forward, mechanical linkages opened the steam valves to the rear cylinders. It was an intuitive, dual-function design. Twisting the bar forward opened the throttle, while twisting it backward applied a primitive spoon brake directly against the iron rim of the front wheel. Roper figured out how to make two wheels move under their own power. More importantly, he created the physical language of twisting a grip to accelerate, the exact same human-machine interface every motorcyclist uses today. By 1894, America was swept up in a massive bicycle craze. Roper wanted to prove the dominance of steam power, so he set out to build a lighter, significantly faster machine specifically designed to act as a pace-setter for the popular velodrome races. This technical line drawing shows the severe mechanical upgrades of the 1894 model. He used a standard Columbia racing bicycle frame, but replaced the pedal crank with a compact, rectangular boiler casing. For the internal fire tubes, Roper repurposed 84 12-gauge shotgun barrels to maximize the heating surface area. The resulting power-to-weight ratio was staggering. The entire machine weighed just 150 pounds, but the boiler was tested to withstand a terrifying 450 pounds of pressure per square inch. In June of 1896, the 72-year-old Roper brought his new machine to a demonstration track near Harvard, the Charles River Velodrome. Firing up the boiler, he pushed the bike to an astonishing 40 miles per hour. As he rolled toward a stop, the machine suddenly wobbled, and Roper fell to the track. An autopsy later revealed he hadn't died from the impact of the crash. The physical exertion and thrill of the high-speed run had caused fatal heart failure. He died pushing an untested, highly pressurized machine to its absolute physical limits. His final ride illustrates the extreme personal risks early inventors accepted to harness mechanical power. We no longer live in an era where inventors casually straddle 450 psi steam bombs. The Wild West bravery of the 1800s has been replaced by strict engineering codes and extreme caution. To prevent the kind of violent ruptures Roper risked every time he lit a firebox, facilities like the National Board Testing Laboratory now run tens of thousands of rigorous tests to certify modern pressure relief devices. Roper relied on a hand pump and basic awareness to keep his boiler from running dry. Today, we mandate the use of highly accurate pressure gauges to strictly monitor equipment limits in real time. Despite all the mechanical relief valves and digital sensors, human error remains a constant variable. Therefore, clear, explicit boiler room warning signs are still required as the final line of defense. We don't have to bravely straddle raw steam boilers to move society forward anymore. But respecting the terrifying physical power of pressure remains the hidden, non-negotiable foundation of our modern industrial world.